It's January week 4 for the Deephaven community team. We've got another great demo for you. So first off, I'm going to show you some of the work I've been doing with embedding iFrames and UI plugins. So I'm presenting my screen. Go over to here. So I'm just booting up my server. And what I've got here is I've just got a couple of iFrames embedded in this static HTML page. So these reference, these are just iFrames with the source set, and I have the name of a table that I want to load in them, and then other parameters such as permissions for if I can copy or if I can't copy. So in this table I can copy, in this table I can't, for example, and in this table I can export CSV when I can't in this table because I don't have that permission there. In addition to that, you can also execute commands. So I'm going to execute a command to sort this table from the console just by posting a message to that iframe, and then that table is now sorted. I can also send a filter command, and now that table is filtered as well. So that's embeddable iframes. The other thing I'm working on is loading plugins from remotes. So let me just refresh this page, and you'll see that it loaded my plugin, the Matplotlib plugin, from the server, rather than having it hard-coded into the UI. And now when I open a Matplotlib figure, it opens up just like it was before. And so that's loading, that's one more step in the right direction from loading UI plugins dynamically. And so that's it from the web UI side. So next up we have JJ, and he's going to show us some stuff with Deephaven Learn.
Okay, so my demo today, we have had a couple of our end users ask specifically about how to do some moving window operations on real-time tables. Excuse me, let me share my screen. And they specifically are using Amanda's Red Panda application, which maintains a live feed of some stock trade data. And so I'll start up her Kafka feed. This particular table has 14 unique symbols in it. There's a whole bunch of tables it brings up. I'm going to use the trades table. And so we had some end users asking about how they could do Bollinger Band analysis. And Chip had presented a couple of ideas for doing it, and I had a third idea which uses Deephaven Learn. So if I run this code, I will keep an active track of the last I believe it's 300 trades for each of the unique symbols in the table. And as soon as this is done running, my performance always slows down a bit when I'm sharing my screen. But as soon as this gets up and running, there'll be a little plot in the corner that shows the live Bollinger analysis for one of the stocks that I keep track of. So I'll move this up here. But this code uses Deephaven Learn, which is kind of intended for artificial intelligence and machine learning to do something a little bit different than that. And I think it's a good demonstration of what can be done with Learn that's outside of that domain. And so with this particular code, I've measured speeds, excuse me, on a per row basis of anywhere from 80 to 300 microseconds per new row. So theoretically, this could keep up with about 3,000 new rows a second at its worst performance. So performance is pretty good, and it all uses Python. So for our potential Python users out there, this is one way that you can do some real-time ops.
All right, very cool. Next up, we have Christian showing us some changes with Big Decimal.
Hello, everybody. So I'm going to do a very small demo about some changes that we did for improving the Big Decimal support as part of the work for doing CDC, change data capture support, and also the Divisium demo used Big Decimal. This happens essentially because it's common in SQL databases to have decimal types in columns that denote things like prices. Because floating point is not a great idea for prices because you have all kinds of rounding errors because of base 2 versus base 10, decimal is base 10, etc. Right? So when you pull in data from a SQL database that has a column in a decimal type, you get that 2 Kafka via Avro in a Avro type decimal, which ends up in Deephaven in a big decimal column, right? For the Java type big decimal. So I'm going to begin sharing my screen now. Okay, so I'm just going to run the Docker Compose for the regular Deephaven image at the top level. This is from main. This is already merged as of like a couple of hours ago. And I'm going to run Web UI here. And I'm just going to create first one table with a couple of big decimal values and some long values. So just 2 columns, a big decimal column here and a column with longs here. Some values there, mostly the first couple of them are zeros, and then we have some small numbers here with a bit of like a decimal part to them. So it used to be that when we needed to do operations that compare big decimals to themselves or big decimal to another type, you needed to type expressions like this that are not like super easy to type, right? The big decimal type in Java has a method called compare to, and then you actually need to pass another big decimal. So if you happen to have a long, you need to convert that long first to big decimals, so you end up typing this long expression here, right? That where statement, actually, when the big decimal value is greater than the long value, it happens to be true only in one row. So we get, just one row. Now it's a little bit easier to write the same thing. You just say that. And to give an example of something also relatively small, arithmetic expression, let's say that we need to take the difference between the big decimal value and the long value. We used to have to write this, big decimal value dot subtract, same thing, convert the long value to big decimal first. You get some results there. The result column is of the expected type, big decimal. And now, hopefully, that's a little bit easier to type. So that's it. That's improved big decimal support.
All right, awesome. That's going to be very useful. Next up, we have Colin showing the plugin usage to load up Pandas DataFrame. So let's get to Colin's screen.
All right, is that working? Can you see my screen?
It's coming
Yes.
up.
All right. So this is by itself, and just visually, not a terribly impressive demo. Just saying, hey, let's import pandas. Let's make a dictionary that has a column with some values, make a data frame out of it. And then once we have the data frame, the table shows up in the UI. We've got 5 rows that are visible. The slightly more impressive part comes out of the fact that we can now treat this pandas data frame on the server just like it's any other Deephaven server. We can build charts out of it, select distinct other aggregations. We can also modify the data. However, due to the nature of Pandas DataFrames not providing a way to get the updates in the UI, we have to actually refresh the client to say, hey, go get that value. And if we've got multiple ways we can change data frames, and all of them just change the objects and provide no way to get hints about the changes as they take place for other clients who are interested. The really interesting part about this is how it was implemented, that we can just say, hey, let's implement an object type from the plugin work that Devin has done. And all we need to do is say, hey, if we've got some example function, some simple function that takes a data frame and transforms it into a Deephaven table, we can say this, I want you to pass this reference to this to the client so that it can talk about it no matter how big it is. And it can reference the server instance of it and subscribe to it, and then return an empty byte string just to say there is nothing else interesting for the client to get. And then in the client code, it's just a matter of saying, hey, now that we have got some way to say, is this a Pandas data frame? If this instance was a Pandas data frame, fetch it just like any other widget, grab its exported object. The only one that's going to be in there will be a table. Go ahead and fetch that and return that to the UI. And with that, that's enough for the UI to be able to say, hey, I can fetch this as a table and display it on the screen.
Very cool. Next up, we have Devin showing some table dogfooding.
Hey. There we go. I should be able to present my screen. I want to talk about using and dogfooding tables from within the Deephaven server and client. Let me find my screen here. I believe it's this screen. Can everybody see my screen now?
Yep.
So right now, the web UI sources this panel information from a subscribe fields RPC. And it's my opinion that we should try to move away from that and try to move to more tabular data. And so I've got an example here of a couple ideas that I'm throwing around where we can present server information to the client as a table. So all these fields that we saw right here are actually in this table exposed via an application mode called application with a field named fields. And so this is the table we're looking at right now. And so this is every application installed in the system, every field that it has along with its type, which Colin just talked about, updating in real time. So I've got an example of a dynamic application down here that's just every time a new row ticks, it will wait that amount of time until it does the next one. So hopefully within the next few seconds, we'll see row 21 here. Shouldn't take more than 21 seconds. And there we go. So you can see it is updating. We've also got an application field that just shows what the applications are. So here's all the applications that we have installed on the server. This other fields table isn't enough information to know what applications are actually installed because there might be an empty application like this one right here. So this one doesn't have any fields actually, but it is an application. So we also need this table to have a complete set of information. And of course, we could join these two tables together if we wanted. Along with what Colin was just demonstrating about object types, it might be nice for a client to be able to ask the server, what custom objects do you know about? And the server could expose that information as a table. And so we've got this object types application right here. And this table right here is just returning all the plugins that it knows about. We've got a figure plugin. Bender showed earlier the matplotlib plugin. There's also a JSON plugin and some other custom plugins that I've installed too. And then the other one that the object types application is exposing is called reserved names. And so these are names that plugins can't use because the server is reserving them. And so this is, kind of static application data that is, maybe something that needs to be documented. But maybe it's useful for the client to have that information too. So it's very easy to take that set from the server and expose it as a table to the client. So that's a brief example, and I'm hoping that we can use and stand up these tables very simply server side, so we can have fast iteration and we could potentially do a lot of interesting stuff with this data from the various clients that we have. Just as a quick example, another example that is not related to Deephaven application state, but you might want to see what's the garbage collection state on the server. So we could, I've got a server-side application. I can go ahead and grab it here, do some plots. And so we could look at the garbage collections that have happened since we've started up. We haven't had any, but if we go ahead and let's read a 50 million line CSV, we should get some GC operations out of that. And so there we go. So there's the GC operations that had, and we can see, we're getting some immediate feedback from the server regarding that state. So I think there's a lot of interesting potential for application mode and returning this type of table data to the client.
All right, very cool. Tabular data is tubular. All right, that's it for this week for the Deephaven community team. So we will see you next week with another demo. Bye.